Hi, I'm Joe, and you're watching Joke. I made a hex node, and I'm going to continue explaining how it works. This is part 3, hex columns. Okay, just a small note before we start the video. I recorded parts 1 and 2 2 weeks before I recorded this, so I may not be as coherent as I was in those two parts in this one, and I'm sorry for that. And also, one more additional thing. I had meant to make this the last video, but it became so long that I couldn't in good conscience release something that long. So this will be part 3 out of 4. But I hope you can still enjoy the video. Okay, so we've reached the end game kind of making this hex node. And now all we need to do, we've done the most difficult part, all we need to do now is turn this hexagon into a grid. So to start doing that, we're going to start off by making this one hexagon into columns of hexagons. So let me get rid of this. Okay, let me take this out because it's just gonna be a mess, this rendering over and over again. So what I'm going to do, I'm going to delete this UV for now. We'll still have the UV input for that. And... okay. Then I'm going to group these. I was thinking about grouping them later, but it seems like it may be best to just group it now. You know what? Actually, we can group this later. So the thing we need to start off with is an offset calculation. Now, I said earlier that the offset calculations will be made later, and later is now. So the offset calculations are pretty simple. We are going to... I actually need to check if there's another node that I haven't created. Okay, there are 2 nodes we need to create. I feel like I'm a bit all over the place. But we need to create the vert calculation node first. The vert calculation gives us the distance between 2 hexagons, and since it should be here. I should have made it here. That's the thing that's weird about this. Delta calculations. Okay, yeah. So here's the thing. The vert calculations in this scenario, because we're making a flat top grid, I'll post up what I'm talking about right now here from the hex grid website we've been using. Since we're making a flat top grid, the vert calculations will be the same as the height, but conceptually, what we're actually calculating is the distance between... It's essentially the... Oh my gosh, this is very confusing. It's essentially delta y, it's height. It's just a thing that keeps repeating in this whole process. So the height of the hexagon is equaled to delta y, which is essentially the change in the y position. So it's just the distance between 2 hexagons, vertically speaking. That was a mouthful. That was a lot. Sorry about that. Either way, we've already made this calculation with the height calculation within this single hex node. So that's actually not that bad. We'll group this. And then all we need to pass in is the size value. Why wouldn't you go in? Okay, so now that we've linked that up, we're just going to call this size so we know what it is. And we're going to go out of here. This should not be clamped. That should not be clamped. That would be really bad if it was clamped. So now that we have this, we can name it our vert calculations. Hopefully I spelled that right. Looks about right. And now we can go into making the rest of the column node. So yet again, to start off the column node, we're going to need to make the offset calculations. To make the offset calculations, we needed the vert calculations. So here, vert calculations will take in size, and that will pass on to a normal math node. This math node will then multiply the results by 0.5, essentially cutting the vert calculation value in half. And half of the vert calculation will then give us the offset value. Now, to group this offset value in the documentation, I put the XY value node. It is actually very unlikely you'll need this. You could actually just use the direct output from this end of value node to do this, but I thought this was just cleaner and easier to understand. So XY, and there's another thing I haven't made, the XY value node. Making this project twice has just messed me up so easily, because now I'm jumping between different nodes. The XY value node is actually pretty simple to create. So what we're going to need here is XYZ combine. Not combine. Yeah, combine works. But we'll also then need I'm trying to think how to do this. Because if we just do this, then group it, it will give me kind of what I was looking for. I just need to delete this vector and also delete this Z. So the XY value node essentially just, you're able to input X, you're able to input Y, and you're able to get X and Y back and forth. My gosh, my mouse is freaking out. Okay, so there. We'll name this XY value node. Now, yet again, this isn't completely necessary. This is just a really good way to show the equation that I'm doing in this process. And for those who are wondering why this isn't as coherent as maybe the first two parts of this, it's because I recorded the first two parts of this a week ago, realized it was too long, and started editing a video. I've edited 2 videos, and now I'm doing the final part. So that's why this might be a bit clunky. Sorry about that. So back to the offset calculations. Now that we have this XY value node, actually I don't know why I call it node, I can just do XY value. We pass in the multiply. I'm gonna safeguard both of these. And then the X value is 0.5. This simply ensures that, yet again, the hexagon appears in the center. That's why we've had 0.5 here. That's why we've had 0.5 here. The Y calculation makes it so that our Y position aligns the top of the hexagon with the top of this plane. You'll see why that's important later, but for now, just trust me, you need it. So now that we have these 3 nodes hooked up properly, we can group them, and we can pass in size for this value, and our outputs will be the vert, the X, and the Y. Let me just move this vert down, and also just name it vert. Don't know why I didn't do that by. Oh, whoops. That's just value there. I could just change that to vert, but I won't. It's named vert here, it's fine. This is now our offset calculation node. We can safeguard that because we're going to use it later. We're actually just going to use it right now. We can move this here, and now we can get started on the rest of our hex column node. So like I said, these values are actually not going to be static. They're going to be pre-calculated values given by our offset calculation node here. Then the vert needs to feed into another node we need to create right now called the UV modulation node. Now, UV modulation is what we need to do to actually multiply a hexagon. So right now I can show you what we have by just feeding this back in here and feeding this here. That's not good. That's not good. We should have because we have no UV. Right, okay, sorry about that. So the UV modulation, very important, gonna come back later. But for now, let me just re-add the UV map and feed that in there. Right, offsets also need to be fed into here and here. It's good that I double checked this. There we go. So with this, you can see that I've placed the center of the hexagon. Ooh, how do I explain this? Okay. The center of the hexagon is half the height of what the hexagon is drawn to, as well as half of the width of the plane that we're on. So yet again, this will be important later. Essentially, to create a hex grid, we're gonna have to chop off this top part. And the only way to do this is if this is perfectly sitting at the bottom. If it's centered, we can't make a good hex grid. We just can't. So yet again, the missing part of this whole system, kind of before we get into, actually, so that we can form the grid, is the UV mapping. Now, yes, while we can feed in the UV mapping, normally that doesn't give us a grid. So let's just take that out. So yet again, this doesn't get bogged down by rendering over and over again. We're just going to take that out of the display socket. So before we get into the UV modulation node, which is essentially the last part of this whole big setup, there is just the general UV nodes that we need to add. So if you're looking at the documentation, you can go down to the last node in the whole document, the hex node. And in the hex node, you'll see a frame called UV nodes. This is the UV setup that we need to make sure our grid forms properly. So yes, it starts with this UV map node. This UV map node gives us the information of the plane that we're drawing to. Following that, we're going to need to make a separate node, kind of similar to this, but with a different purpose. We're essentially going to transform, wait, not the offset, sorry, my bad. We're going to transform XY value into a 3-vector node. Now, this is cumbersome. You could just actually use a normal vector node. Vector transform. This will essentially point. This will give you the same results if you entered the values in here and here and set this to 0. But this was just, it's frustrating to me that they don't have like 2D nodes and 3D nodes. So What I did in the documentation is that I transformed this into a 2D vector node. So let's just delete that. This node is extremely simple. It's essentially just the combine XYZ node. Set that to a group and remove Z. Just leave Z as 0. Then delete Z from here. There you now have your 2D vector node. During the whole process of making this giant hex node, I caught some redundancies. One of the redundancies was me leaving an XY value node within this node. It was completely unnecessary, so that is just a simplified version of what I originally made. So now that we have the UV node, we have the 2D vector node. The 2D vector node will accept some other inputs that we'll talk about later, but right now we're just trying to build the framework for the UV nodes. So next we need a vector math node. This will add the UV vector to our 2D vector here. Following that, let's duplicate this again. We are now, whoops, nope, not that one. Actually, we need a vector rotation node. So now with vector rotate, we'll feed this in for the vector. The center will be 0, 0, 0, and the axis will just switch this value to the z-axis. Since this is a plane, we're only spinning it in 2D, the z-axis, as you can see here, is the only axis not visible. That's because it's the axis looking directly into the plane. So this will be used to rotate it. This will be used to displace it. Then we need another 2D vector node right here, followed by multiplication, because the next thing will be scaling it. For those who know maybe vector maths or even just game development, programming, graphics programming, like anything in that realm, you'll know position, rotation, scale. That is essentially what we've made here. That is all we've made here. So with that setup, we can now start making the custom nodes that involve the UV. The first of which is the last of these UV nodes, called the UV negative correction or negate correction. I think I'm going to call it negative correction. So the UV negative correction node essentially makes sure that if we get any negative values for UV, which would happen if our position was moved in the negative, that it's corrected so that the math appear. So the computer reads negative values as positive values. So even if we get negative positions, it generates the hexagon as if it were positive. You know, actually, to show what I'm thinking about or what I'm representing, let's build the UV modulation first so you can see what the grid looks like without negative correction. So, okay, the UV modulation node. The UV modulation node, pretty simple. It doesn't really include a lot of custom nodes. It does involve simple maths, at least if you know the modulo function. So to start off, we're going to need a separate XYZ node because we're going to be dealing with X and Y separately. We're then going to need three math nodes. I was going to say a bunch of math nodes, but a bunch is like five or more is a bunch. I don't know how much a bushel is. I think a bushel is specifically used in fruits. So we have our math node. Let's get 3 of those. I'm just doing it in like random space. I should have picked out a corner that I could sit in and figure out, hey, these nodes need to be arranged this way. Either way, now that we have that like that, we just make this multiplication. We feed the y into this top value here. We make this one modulo. And we make this one modulo. This multiplication will be fed up to this top value here because the modulation for y is the modulation for x is a bit different and the modulation for y is a bit different and has to be calculated off the width of a hexagon and also the height of a hexagon. So specifically the modulation for the x modulation is within 2 widths, which will give us a hexagon for every 2 widths of a hexagon. While the modulation for the height is simply the height of a hexagon. So for every height of a hexagon, we'll print another hexagon. You'll see what I'm talking about when we hook everything up correctly. So with that, I believe the only thing I have left now is... I'm going to put that there because that's actually supposed to go there. The only thing I have now is the combine XYZ. So Shift A, combine XYZ. We'll put that in for X, we'll put that in for Y, and we don't care about the Z. With that, I'm thinking. Let's just feed the vert in like this, because vert is what we need for this multiply value here. Then delta X is needed here. I'm just trying to set this up so we're in a good position for when we group them. Change that to a 2. We're doing twice the delta X yet again for every 2 widths of a hexagon, essentially for every 2 delta X's. We want to print another hexagon. Okay, so with that, it looks like we're all set up. I think everything's plugged into the right place. We'll find out soon enough. Control G. Everything's grouped the way it's supposed to be grouped. Let's make it match the documentation. We're going to put this at the top. We're going to call it UV. This is delta X. And this is vert. Okay, now that we have all those values lined up like they do in the documentation, you will see that I messed up something. I forgot to hook up Z. Then this goes out. And that is your altered UV. You can name it UV. So if we exit this, this is now our UV modulation node. It's what creates the grid that will appear on the plane. So we can name it UV modulation. I'm not even sure if modulation is the right word. It's just kind of the word I'm using right now. So now with UV modulation properly set up, I'm just going to move it into the position it is in the documentation. And I'm going to plug this in here. We're going to protect this. We definitely need to protect this. It is very instrumental. And oh, shoot, I forgot last time. I didn't name this. This is the hex drawer. We can also protect that. So with everything protected, everything the way it's supposed to be, yada, yada, yada. It looks like everything's hooked up correctly. let's just see how we did. There, so now you see the hexagon is actually replicating. Once we add in scaling and position, you'll see that it's starting to generate a grid, or at least half a grid. You know what, let me demonstrate. So if you take this, we're not really, this is supposed to be multiply. That's what's happening. Multiply 1 by 1, you'll see we have that. Now if we nope, that's scaling the wrong way. If we scale it by 4 and by 4, we now have what should be a 4 by 4 grid. Essentially it is printing 4, 1, 2, 3, 4 full hexagons, each 2 hexagons apart. So this is what I mean by the hexagon column node. Because this just generates hex columns. But if we set the position to negative, you'll notice it's not printing any hexagons this way. So that's why we need the hex or the UV negation correction node. That is such a difficult node to say. I don't know why I named it that. I'm so sorry for everyone who has to like name it that or list it that. If you can think of a better name, please call it by a better name. Okay, so the UV negative correction node, yet again, still a mouthful, is just this huge math block. Because it's this huge math block, I'm gonna do what I should have done with the UV modulation node and just go to an empty space. In fact, I'm gonna go into nodes. I need this space. This can go away. So to start off, the UV negative correction node, yet again, still a mouthful. My gosh, I'm gonna say that a lot. Apologies. We're gonna do a separate XYZ. Just the naming of this node, I hate it so much. And I did it. I should not be on like naming committees or anything. Either way, that's besides the point. Next, we need a math node. In fact, we need 9 math nodes. I told you this was a huge math block. Duplicate it, and duplicate it again. So yeah, this is a huge math block. I'm gonna be so sad if none of this is recording. Because I'm gonna have to do it again. I'm gonna be upset. I'm gonna do it tomorrow. Because I have no energy after this. So we plug in X, we plug in Y, we plug in Z. Okay, nope, that was wrong. We plug in Z. Make sure everything is plugged in the right place. We learned our lesson last time. So, here's the thing. We only need to ever do this math if this is less than 0. So if this is less than 0, I can clamp this value because we should only be getting a 1 or a 0. It really doesn't matter. So if this is less than 0, we pass on the value to the multiplier. This multiplier ensures that we only do this math, yet again, if everything is less than 0. We could also clamp that, but mathematically actually doesn't make sense to clamp that. It makes sense to clamp that because we should only ever get a 0 and a 1. But out of a multiply, we can get a bunch of stuff, even though in this case we're only getting a 0 or a 1. You know, as I'm thinking about this, as I'm looking at the documentation, this isn't needed here. This is only so it can mirror everything else. I'll explain later and show you how to make a simplified version of this. But first, we're going to do this. Multiply by our... subtract our... I'm frustrating sometimes. Okay, this is either 0 or 1. If it is 0, this will return 1. 1 will multiply 1, and 1 will go here. So, our x value, if it is negative, yet again, pass through, this will equal 1. We're going to minus 1 from negative 1. A negative value. I'm just thinking through this. Is this necessary? This might actually just fully turn out to be unnecessary, but for now, let's leave it. The more important part is what we're going to do with this y value. Now, y cannot be manipulated willy-nilly like x can, because I'm pretty sure all of this is kind of useless now that I'm looking back at it. So yet again, we only do this if this is less than 0, meaning it's negative. If it's less than 0, we're going to multiply the 0 or the 1 by a vert calculation. Why are we doing it times a vert calculation? I'll tell you in just a sec. So, the reason we're multiplying the y value by the vert calculation... Nope, that's incorrect. Sorry. The reason we're multiplying the vert calculation by the result of the less than function is because if y is negative, we need to correct it by the vert calculation, because our y is our vertical on our Cartesian coordinate system. So, if our y is negative, we need to correct the negative y. Sorry. If our y is negative, we need to correct it by its essentially delta y value. Because this means that we are... How do I explain this? We're moving past a certain section of the grid. This section of the grid cannot be properly mathematically generated. If you generate it, you get weird patterns when you cross over into negatives that are just not hexagons. So to correct it, we skip over a certain section of y values and a certain section of x values. The x values are easier to calculate. That's why we have this simple subtraction up here. The y values, we have to do the vert because it's not a simple 1 or 0 kind of thing. It's either by the vert or not by the vert. Hopefully that made sense. Hopefully when we get to it, you can visualize it better. But for now, let's just continue on and make our negative correction node. So yet again, we're changing this into a subtract block. We're passing in the y value because we're altering the original y value we get. then this is all essentially kind of useless for the Z, except if you're simulating like a rotated plane. That is the only reason we account for the Z in this. We'll pass this here, yet again multiply by 1. This is essentially getting the same treatment as the X, because if you rotate in a simulated Z, you're not affecting like the weird height math we're doing with the Y. The X is essentially the width of the plane anyways, so that's why it's getting the same treatment. The Z should essentially be nothing to the plane, except altering your perspective of how you're seeing it. So then we pass Z into this last subtract. Change it to subtract. And there we go. Now with all this, we recombine them. And we add another vector node. Vector math node, sorry. In this vector math node, we're going to get the absolute. The absolute of this vector simply just ensures that all the values should be positive. And that's it. So now we can select all of this, we can group it. It was a long and arduous process. However, at the end of the day, we made it. We can plug this in here, that's going to be UV, and we can plug this in here, that's going to be size. So if I get this tab back open, we get size and UV. Then we can return this, it is going to be UV. In the documentation, I just left it as vector because I really wasn't sure what to call it. I was going to call it like adjusted UV, something like that. But it's just a UV value. It's the UV value that we're going to be using. With that, we can now name this the most cumbersome name in all of node history, UV negative correction. I talked way too much for this. We can now just pass in the UV value through this. It negative corrects, and if we go back to the shading tab, how have I failed this? Okay, give me a second.
A few moments later.
Okay, this, unlike all my other mistakes, was a pretty quick solve. This is supposed to be less than. Nope. Give me a sec. Less than. 0. We'll clamp that. This is supposed to be multiply by 1. We have that, and there we go. Now to demonstrate what I meant by the correction for negative. So if we go negative now, you'll see we're still generating hexagons. As we go negative, and as we go negative y, we're still generating hexagons. So yeah, there we have it. That is what I meant by the UV negative correction. So now for any negative value for the UV we get, we've corrected it so that the hexagon still generates. Okay, with all of that, we kind of have everything we need to close this out. All we need to do is finalize the hex column node. And then we can finally make our hex node, our completed hex node. So the hex column node is essentially just this structure over here. We've had the hex column node for a while. However, I did need to show you all how to complete the UV section before we got into this. Actually, to complete out the UV section, we need to put this in a frame. So let's do that. You can Shift A. Remember, you need Node Wrangler enabled in your preferences. Create a frame, and we can just dump this all in there. Nope, I'm not selecting you, frame. You are actually very, very much so not invited to this party. You are hosting the party. Move that in there. Let me grab you. This then allows us to just grab this whole group. It's not a node unto itself. It is just a group of nodes working to properly give us our UV values. So we'll call this UV nodes. Everything UV related just goes in here. Then gets outputs into what will now be, as we work on it, our column node. So our hex column node, we've already built it out. We just need to make sure all the proper outputs get dealt with. So size goes here and size goes here. We're also going to add margin in here because that will be an external input. And that all just gives us our 0, 1 value that generates this whole thing. So if you now go out, yeah, this looks about right. This is now our hex column node. Okay, we're stopping here for now. I know that was a long one. Thanks for making it this far, if you did. And if you want the documentation for this project along with a bunch of other stuff, it's in the description down below. And if you want to review the last 2 installments of this, please click up here to the left where I have a playlist of the hex node tutorial. And if you want to catch some of my other work, please click up here to the right where I have a playlist full of it. And if you want to catch the next installment of this project, please hit that notification bell and subscribe for more. Thanks for watching, and joke out!